All right, so let's do another example of an energy flow diagram, this time involving a bowling ball. And we have me going to lift the bowling ball onto the table. And then at the end, there's the bowling ball on the table, right? Not so bad. But this time we're going to do it a little different. In my last video, we put everything inside the system. This time we're going to list all the objects, but we're not going to put everything in the system. So in the system, stupid bowling ball. In the system, we're going to put the bowling ball, the table, the earth, and the floor. Remember, we're listing, we got to include all of the objects that could put a force on another object that we're listing. Now, we forgot Mr. Dickey, but we're going to put Mr. Dickey outside of the system. That doesn't mean I don't exist. It just means I'm not in the system. We could literally decide to take anything into or out of the system, and it would be okay. It just depends on how we want to think about our problem solving. So, now, what we do is we ask the same questions we did originally, right? Is anything above its lowest point inside the system? Nope. Is anything moving inside the system? Nope. And is anything a spring that's compressed or stretched inside the system? Not so much. All right, so then we come over to the end and we ask the questions again. Is anything above its lowest point? Well, clearly the bowling ball moved up, so we've got some gravitational energy. Is anything moving in the system? Not did anything move, but is anything moving at this instant? And at this instant, no. The bowling ball table and Mr. Dickey are all stationary and still, so no kinetic. There's no springs. Now, do we have any reason to expect any lost energy inside our system? Well, there was no rubbing of surfaces, no impacts, so we have no expectation of lost energy in this case. But we do have some gravitational, so let's give us, 3 blocks of gravitational just for the heck of it. But we have a problem because we have no blocks and suddenly we have blocks. Where did those blocks come from? Well, we know where those blocks came from. I gave those blocks to the system. So we draw those blocks right here on me, and then we draw an arrow to indicate that these blocks entered the system. These blocks entered the system. Not so bad, right? All right. What's our conservation of energy equation going to look like this time? Well, we have nothing equals something. But we can't do it that way. So what we do instead is we have work, right? Because we remember anytime we have energy crossing our system boundary, we call that work. So we say work equals our gravitational energy. Not so bad. And the reason this can be a powerful technique to solve problems is we know work. We know that work equals force times our displacement. We know that. And so now we can do something with that. Because if Mr. Dickey was in the system, I would have to give me food energy, right? Because that's what I use, food energy or chemical energy. I don't have a formula for chemical energy. I do, however, have a formula for work. So that works out nicely. Now, let's do another example. All right, so in this example, it's different in that I have the bowling ball starting on the table, and then at the end, the bowling ball is on the floor. And in fact, I'm going to just let it fall to the floor. We're just going to give it a little push, and it'll fall to the floor and eventually come to rest. So this is the instant it's on the table, and this is the instant after it came to rest on the floor. All right, so now let's define our system. This time I'm going to put Mr. Dickey in the system. I'm going to put the bowling ball in the system. I'm going to put the table and the floor in the system, but this time I'm going to take the earth out of the system. All right? So, what does that look like? At the beginning, do we have any gravitational energy? Well, if the Earth is outside of our system, then there's no gravitational energy inside of our system. Kinetic energy? Nope. Gravitational or elastic energy? Not so much. Over here? Do we have nope, we can't have gravitational because the Earth's out of our system. Kinetic energy? Nope. Elastic energy? Not so much. Lost energy. Well, anytime we have an impact, we know some of our energy gets lost as thermal energy. So we call that lost energy. So let's give it 3 blocks of lost energy. But again, just like before, we have no energy equaling energy, but we do have the Earth. And the Earth is what put that energy into the system. So we're going to put these 3 blocks here, and again, it went into the system. So in this case, work equals lost energy. And again, this is kind of cool because now, again, we don't have a formula for lost energy, but I do have a formula for work. So now I could actually calculate the amount of lost energy by using this conservation of energy equation. Pretty cool.